Hi, my name's Brad, and I'm going to show you how Fabra Fuse is pushing the boundaries of how injection molding tooling is being manufactured. Just the other day, Polymaker, they launched their HT-PLA and HT-PLA-GF filaments onto the market. And at its price point, it's got extremely high temperature resistance. So what we did is we got some filament and we made some simple tools and we put it into our prototyping injection molding machine, and we just saw how it performs. So let's take a closer look in how the HT-PLA stacks up against some other common filaments from the Polymaker lineup. In this chart, you'll see price in ascending order, and then the HDT or the heat resistance values of each of those filaments. The way that breaks down is shown in the next chart. So what you have is actually a annealed HT-PLA hitting way above its weight relative to its cost, with almost 4 degrees of heat deflection temperature per euro that you're paying. So that's why I think it's kind of a sweet spot for possibly the lower end thermoplastics for the injection molding applications. And that's why we decided to go with an HDPE for the trials. It has a processing temperature of 150 degrees, and that's what we were using for the entire trial. So the only thing we had left to do is to start making some injection molding tooling. We used their teal HT-PLA, the Power Tool red HT-PLA-GF, and I'll run you through some of the process and the results that we ended up with. Here's the part getting injected. The metal ring is actually the contact surface between the nozzle and the tool. We ended up making 13 HDPE parts, and I'm happy with how it turned out. Initially, I wasn't certain if we were even going to get the tool halves apart after the first shot. And because of that, I did over-inject in the beginning to give myself a better chance of getting them to pull apart, and you can see those witness lines. Next up, we shot a HT-PLA-GF tool. We were more cautious about filling this properly, not to cause substantial damage in the beginning to the parting lines. And we ended up with a very good surface finish, minus the sink marks around the outside. So HDPE has a high shrinkage value, it's quite soft, and will tend to have sink marks rather than voids, like a glass fiber reinforced thermoplastic, for example. And the tool itself performed quite well. So we had 4 or 5 parts off of this, and there's no substantial wear. You can see it's a little bit glossy in some areas that end up with some flash. The next part, we dropped the wall thickness from 4 millimeters down to 2 millimeters. It reduced the shrinkage and the sink marks that we were seeing on the part. However, we did need to increase the injection pressure to compensate for that. So the black portion of the tool is a standard PLA with carbon fiber reinforcement, so a low heat deflection temperature. The red portion, of course, being the HT-PLA-GF. And you can see here the injection point is quite washed out from the high injection pressures on especially the PLA-CF. The last tool that we ended up running was the same design as the first, but we wanted to see what the thickness of the form halves would have for an effect on the longevity of the tool. So you can see here the thin strips in between the first tool. That's to give it enough height to go into the clamping unit. The part actually ended up being very similar to the first tool. It actually was run with the same parameters, so that's not very surprising. However, by sandwiching the tool halves into the first tool, we weren't supporting the back of the cavities correctly, and it ended up breaking after only a couple shots. But we did reduce the tool weight from 500 grams down to 56. So what's my feeling about using HT-PLA or HT-PLA-GF for injection molding tool inserts? Is it going to get you the widest range of thermoplastics processed? No, it's going to be limited to your lower melt temperature polymers. Will it get you the most amount of cycles out of a tool that you've seen? For sure not. You're going to be limited to a handful of parts. But often in a prototyping phase, it's not necessarily the stability that you're looking for, it's the speed and cost. And I think HT-PLAs could be an interesting solution for soft tooling. So if you're looking at getting something processed, if it's maybe a polypropylene or a glass fiber reinforced polypropylene, we could maybe even use the HT-PLA as a solution for you. Reach out to our team. We do have different polymers. We're not just restricted to your PLAs. We're using liquid crystal polymers for higher temp tool inserts. So even at that, let us know and maybe we can get you a solution. If you're interested in seeing more content like this, for us trying different tool materials to try and inject different materials onto those tools, let us know in the comments what you are looking to see, and maybe we can get a video put out in the future for that. So thank you for watching, and I wish you a great day.